All right, now let's finish up this. I got interrupted this morning and then I've been busy till now. So anyway, solve this. So this is a parabola. You should recognize that. It's a quadratic equation that would make a parabola. And it's going to be since the coefficient of the x squared term is -4, means it's going to be an upside down parabola. And so if it crosses the x-axis, wherever it crosses the x-axis, the x-intercepts, between the x-intercepts, the parabola's y-value is a positive number, greater than 0. And on the two wings here, if we want to call them that, on the two ends of this parabola, they would be, the y-values are less than 0. And it says the whole y-value is less than or equal to 0, so we want to get the x's that make this parabola go down, and that's the x's out here and the x's over here, or equal to 0. So first of all, we got to find the intercepts, which you can do by factoring or quadratic formula. So I'll do the quadratic formula here. So a is -4, b is 13, c is -3. So x equals the opposite of b plus or minus the square root of b squared. 13 times 13 is 169, plus a -4 times a times c. Well, a times c is 12 times a -4 is -144, all over 2 times a. 2 times -4 is -8. So 169 minus 144 is 25. How convenient. Square root of 25 is 5. So -13 plus 5 is -8 over -8 is 1. -13 minus 5 is -18 over -8 is, let's see, 2 would go into these and be 9/4, positive 9/4, or 2.25 or 2 1/4, whatever. So this parabola hits the x-axis at 1 and 2 1/4. 1 is here and 2 1/4 is here. And this actually factors to, if you were to factor it, it'd be, we don't like to factor with a minus in front, so I could multiply everything by -1 and have 4x squared minus 13x plus 3, and I would do 4x and x. It could have been 2x and 2x, but it turns out to be 4. I can tell because it's a quarter. I'm going to have to divide by 4. And let's see, 3 is 1 and 3, and I got to get 13, so 4 times 3 is 12. And if I make it a -3, that's -12, and 3 times and -1, and so I get I'm not getting the same here. Let's see, that'd be -12 and -1 is -13. This would be at add 1, be at 1/4. I didn't get 1/4 here. What am I doing wrong here? If I multiply by negative, that's plus 4 minus 13 plus 3. This is saying 3 and 1/4. And this didn't say that. What did I do wrong here? I got to figure this out. -13 plus or minus 13 squared is 169. 3 times 4 is 12. Times 4, oh, it's 48. There's my mistake. 4 times 3, -4 times -3 is positive 12, times 4 is 48. 169 minus 48 is 121. And the square root of that is 11. So I should be doing negative 13 plus 11, which is 2 over negative 8. So plus 2 over negative 8, which is 1/4 negative, which is what this, no, should be positive. Negative 13 plus 11 is negative 2. So this is plus 1/4. Man, I'm making a lot of mistakes here. And then that's what happens when you get frazzled here. Okay, negative 13 minus 11, that's going to be negative 24 over negative 8, which is positive 3. So it crosses at negative 1/4 and 3. Now, if you're taking the test, I would recommend that you graph it and just kind of look at it, make sure you got the right answers. I made a mistake in here I got going too fast and got 144. I took 12 times 12 instead of 12 times negative 4, which is negative 48. So that messed me up. Glad I factored and checked it. So now how do I express my solution? Well, this is where it's equal to 0. This is where it's equal to 0, but I want it to be less than 0. That would be for the x's down here. The parabola is below the y-axis. The y values are negative. The y values are negative. Happens from negative infinity up to 1/4, and it's equal to 0 at 1/4, so I can include it because it says equal. Or I can go from 3 to infinity, and I can include the 3. So there's interval notation for the solution. This is what x can be. Now you could also write it in set notation. That would be set whose elements are x such that x is less than or equal to 1/4, or x is greater than or equal to 3. That's 6. Sorry about the mistakes. All right, 7. A salesperson is paid $30,000 a year plus $250 for each sale made. Write a mathematical model. So if you were struggling with this and can't just write it straight out, you can make a couple of points. That if they sold nothing, sold no vehicles, each sale made had no sales, and this is the number of sales, and this is the pay. So sold none, they would get the 30,000, although they may lose their job for not selling anything. If they sold one, they would get 30,250, and two would be 30,500. And you can see how we're getting some points here, and you could plug those into the calculator and use the calculator to find it. You could find the slope and do point slope, but you could also just say the amount of pay they get is going to equal to $250 times every sale plus 30,000 per year. How many sales were made if the income was $65,750? So we would put that income there. $65,750 is equal to $250 per sale plus the $30,000 that they get as a salary. And if you subtract that from there, you get 35,750 is 250 times the number of sales. And so if you divide by 250, how many 250s it takes to make that, how many sales does it take? Well, there's 3 in that, and then 4 in every 1,000, and there's 35,000, so 4 times that's 143. Is that how many sales there are? I'll get my calculator out here and confirm that. So I would take on 35, get out of that, 35750 divided by 250, 143 sales. Okay? The last problem, write an appropriate mathematical model for the following data. So we would have to see whether it is linear or not before we can decide which model to use. So to do that, I would go to Stat, Edit, and I would go to List 1 and clear it, and List 2 and clear it. Then I would come back and put in the numbers, 1.2, enter, 1.5, enter, 1.6, enter, 1.9, enter, 2.3, enter, 0.5, enter, 0.2, enter, and 3.1, enter. Put in the y values, make sure I get them across from the right ones. 4.23 is across from 1.2, 4.03, 3.93, 3.62, 3.11, 4.63, 4.69, 1.82. Got the same number in each list, so now I can go ahead and turn a stat plot on. I'll turn number 1 on, and I'll make it a scatter plot using list 1 for my x's and list 2 and making those kind of dots. Press y equal, make sure there's no equations graphing, so I'm going to clear that equation, clear that one. Then I'm going to, instead of just graph, I'm going to zoom to fit my data, which is statistics, so I'm going to use zoom stat, which is number 9. Press enter, and it graphs them, and I somehow got a strange point in there. I better go check my data. Edit. I had 1.2, 4.23, 1.5, 4.03, 1.6, 3.93, 1.9, 3.62, 2.3, 3.11, 0.5, 4.63, 0.2, 4.69, and the last one, 3.1 should have been 1.82, and I had 4.82, 1.82, 1.82, not 28, enter. So zoom 9 again. Now if I look at that data, it almost straight, but it looks like it's curving down. So therefore, I should find a quadratic that fits through it, a parabola. And I could just take the 3 points and use that, but the calculator, stat, can calculate a quadratic that goes through list 1 with the x's, comma, list 2 for the y's, comma, and I can actually put it into y1 by pushing vars, y variable, function, y1. Now if I press enter, I get the model, y equals negative 0.2995, that would be 0.30x squared, minus 0.014x, and then finally plus 4.7. And let's see how well it fits by pushing graph. And that parabola hits it pretty darn good. And if I go back to the where it calculated it, when r squared is really close to 1, that means it's a good fit. And 0.999 is really close to 1. So there it's quadratic, because, and I should probably explain, because data curves in a graph. Okay, so there we go.